Thank you for being here. I will be talking about event sourcing and what I've been doing for the last 3 years now. Well, I really began working on it 3 years ago, so we have more than 2 years of it in production, and well, we'd like to give you feedback. A bit about me. So I am François Laroche. I am a Scala developer. Well, I've been a Scala developer for quite a few years now. I really love Scala and well, I'm enjoying programming with it. You can find me on GitHub if you want. And a few years ago, I joined make.org, and we'll talk to you more about it with some objective to create something new from scratch. And that's what we'll be talking about. So what we will be talking about first, I want to talk a bit to you about make.org and our application, because well, the technical part is important, but it's important to me, I think, to understand what we are doing, what kind of problems we're trying to solve, to understand why we are using this or that way to solve them. Then I will talk about learnings on the development side. So, well, how we had to architecture the application, handle actors, and so on. And then I will talk about the operational side, which is also very important because, well, if the application doesn't run well, then it's just useless. And we learned a lot of both sides, maybe more on the operational side, but both sides learned taught us a lot of stuff. So first, about make.org. So we are a company that delivers consultations, which means that we ask people what they think of something. We ask some very general question, like for instance, how to fight against violence to women, or how to better take care of our elders. Well, we try to have some society themes, and for all of them, so we have a first phase where we are asking people what they think of it. A second phase where we're trying all together to see what we should do to make things better, and third phase, which goes to action and try to have things to solve this kind of problem. What our application does is the first part, which is the consultation part and asking people what we should do to solve some problem. So if we can see, this is a screen of the application. We have several parts in it. Here we have what we call a proposal, which is well, the text of what we should do. There is then the possibility to vote on it. So on this one, we voted agreed, and to say why we agree, or to tell a bit more, say if we really liked it, if we think, yeah, we agree, but well, it's quite obvious or whatever. And in the bottom, we see that we have some more general, some referential data about what is the operation. So this one was about environment. And we see that, well, in this application, we have stuff that is used differently. We have, well, if you look on the top, there will be some users' informations, which will not move a lot, but will be read quite often, I guess. We have then the proposal part, which will be very our hot data, which will move a lot. We have a lot of votes and qualifications. And we have the referential data, which will almost never move. So let's start with what we learned on the development side. So first, why did we choose akka? What were we expecting when I chose akka? Well, I was first wanting performance. Akka, well, I chose it for event sourcing and with the state always in memory, which is always great for performance. It is also ready for high loads, and since it can be distributed, it can you can add easily nodes and make it work with better performance. And last of all, because well, we wanted something data native, we wanted that well, everything in the application can be then analyzed easily with data with the data scientists. And since akka is based on messages, it's quite easy to share messages and have everyone work on these messages. So first of all, I will just well, give a few definitions back to what we are talking about. So first, the akka actors. So akka actors are entities that are monothreaded and that will usually encapsulate a state. Why do they encapsulate a state? Because since they are monothreaded, you don't have to worry about anything to mutate the state and so on, since only one thread should be able to access the state. So it removes a lot of issues you can have when you have multi-threaded programs. These actors just communicate together or with the external world using messages, which can be just plain Scala objects. And thus, since we are not using methods but messages, well, it just introduces quite a few other patterns than the one we usually use. And if you are familiar with what we call EIPs, Enterprise Integration Patterns, then actors will sound way more familiar. So I would recommend that you, if you want to really to go further on actors, that you could read about that. Of course, it's quite a low level, but it's really interesting to read how just being message driven changes the way everything behaves. Next, so we have actors. Next is event sourcing. That means that for us, it's the proposals. So everything that people proposed are actors, are entities for us. So there will be one actor per proposal, and you can access it quite easily by sending it a message. In the event sourcing world, we call this message commands. The actor will then validate the commands and will emit, or not if the command is not valid, events that will be then stored in our event store that is for us Cassandra. So which means that the state of an actor is just made by reading every event to create the state back. Of course, when you have hundreds of events, or maybe thousands, well, it's not very convenient to read every event every time. It can take quite a lot of time. So you can just, at some point of time, create snapshots. For example, you will say, at event 1000, I have a snapshot of it. So you will have to read only message events after the 1000th, and you will be done. This is great, but this also addresses another problem, is that it's easy to read a state, but you cannot, well, search for anything. So you really need something else with it. And we see that if write request or the commands have a command, well, how should I say, have different uses. For example, we have a command to accept a proposal, we have a command for voting, we have a command for qualifications, and every command is very different and should have its own data model. And this data model is very different from the needs of the read model. So we need to have a difference between command and queries, which is the other pattern, which is called CQRS, where we are indexing everything in a search engine, which is Elasticsearch for us. And all the read commands, or the read queries, I mean, will then be able to use it to have some rich queries to search for proposals. Next, I will talk about sharding. So as we see, an actor just emits events, but the actor stays in memory. So what would be the worst for event sourcing is to have different writers, so actors that would emit events for the same entity. So we need a guarantee that an entity is only once in our cluster. So that's what sharding is giving us. So when we are sharding, all our entities will be divided in regions. So here S0, S1, and 3, and so on. And so if you want to send a message to an actor, well, you first send a message to a coordinator, which is run on every node. The coordinator will know on which shard the entity is, and will then pass the message to the shard that will then be able to reach the actual actor. So what we see with that is, first, we have only one actor for a given entity at a time on the cluster, which is what we want. And second one, whenever you want to talk to an actor, well, you should expect to go on the network. Next, I will talk about our architecture. So we have first one block that I've called event sourcing, which is the hot data, which are proposals and all the interactions of the user, which is the sessions, which means all that is done by users that are not connected, or users, which is user connected. We have all the auth part, which is well, authentication and users. We have referential. Well, it's just a CRUD. So we have our tags, IDs, consultations, and so on, which is data that almost never moves. So this one, that didn't make sense to me to have it in some akka, or at least in event sourcing. And at last, we have some tracking, which are events that just go through everything to just go to Kafka or to the monitoring. So next, I want to talk to you about talking to actors, which is a part where we had a few issues that, well, we think finishing to resolve right now, to be honest. First one, so to talk to an actor, you need an actor ref, which is some kind of address to the actor. And to the actor ref, you send a message, here in this case, which is YOLO. So it can be anything. That's what I meant using this kind of message. And you have also another way to communicate with it, which is the ask pattern, using the question mark. We just say, I am expecting the actor to answer something. So of course, this kind of method is just the worst you could do, and no one would want this kind of code in your application, because, well, first, you don't know how to retrieve your actor ref. How can you make sure that the actor you're talking to is the one you want to talk to? And first, well, what messages should you send, and why should you send them, and what should you expect? So the first thing is to define a protocol. So just in your actor, just define classes that you want to use in input and output. It's very important to have both. It's important also to have some kind of trait to mark all this protocol, because since every of these objects will be sent to the network, they must be serialized properly. So here we have defined our protocol here. And if we use it now, we see that our code is way more readable. So the first one, we just notice an actor that the user has clicked on some button, and then we ask for votes, and we can then transform them to some useful type, which is better, but still some things are missing. First one, we still have the problem of the actor ref, which means that every code wanting to talk to this actor needs to retrieve the correct actor ref. Then we have the issue of, are we sure that these objects are the ones we want to send, and how can we make sure that we have the actor answers us what we expect to. I mean, every code asking this actor for votes will need to say, okay, I know that this is user votes in return, and well, it's quite of repetitions and gives us the possibility to make quite a lot of errors. So of course, akka-type answers a few of these issues, but well, what we've been doing is what we call facades, which means that well, it's just some plain service, let's say, some singleton that you will then pass to everyone calling this actor. So you still have the issue of what actor ref you use, but in this time you only have to retrieve it once, so it's less error prone. And then this is just some plain service that will facade the actor protocol. So what's nice with this kind of pattern is that you have some types you're used to, and you're just getting out of the akka world quite quickly, which is well, which makes a better integration with other libraries and so on. So I would recommend you to do this kind of stuff, even with typed actors. I feel like it's still good to have this kind of patterns. Next, so everything is asynchronous. So if you have watched the previous conference about reactive manifesto and so on, that's it. So everything is mostly made with futures. We should not block of course, that is well, a modern app should avoid blocking every time. And if it does block, well, it should be very identified. And what we have is that most Scala libraries will use futures. So, well, whatever we want to do, it's hard to get out of the future. So future is good and bad at the same time. It is non-blocking, so it's reactive. It's great. It's easy to create one and so on. It can be composed with well, things that look quite familiar, like map or flat map. It's quite standard, but it's not a real monad, because every time you want to change it, you have to provide some implicit execution context. And it's really cumbersome because you have two solutions. First one is to ask for an execution context in every of your service method. And then it's like polluting everything with some implementation details, which is, according to me, not good. Or the other one is to provide, to import implicitly some execution context, which is not good either, because, well, sometimes you will want your thread to execute somewhere else. So to me, there is no good solution on that. We've rather been on the provide execution context method, but still, since we provide it, it's really hard, I could say even impossible, to control the actual parallelisms of some tasks, because if you start some task in a dedicated thread pool, then whenever you do flat map or whatever, well, you will probably go to another thread pool, and then you cannot, with futures only, control your parallelism. If you want to do something better, you need to use akka-streams. So akka-stream uses back pressure, so to limit to the slowest element. And you have the map async tool method that will then guarantees you that you will not have more threads than what you need, since you will wait for the thread, well, for the future to complete before calling a new one, which is really great. akka-stream also provide graphs. I would discourage you from using them unless you really, really need them, because first, well, they are quite tricky and quite harder to read and debug. And last thing, well, we have some issues, for example, with stream terminations, where we have some stream where for which graphs would be a good use case, but the graph for some, well, the reason was well defined, but the graph did not finish because, well, it had no way to know it had no way to know whether the graph was over or not. And so, well, we couldn't use it for that, and we were back to using some other ways to do it. So avoid the graph if you can, and use the stream extensively. Well, we skipped this one. Another thing I would want to talk is about event migration. So, as I said earlier, the actor will receive commands and emit events, which is great. Events are then stored in some event store, and after some time, well, not unfortunately, but after some time, well, you will have some new features in your application, and you will want to change a few things in your events. Well, of course, you will add new events, but you will want to modify all the events. For instance, in our application, at some point, we added the country and the language on every event. So event migration is something that is normal in any event application, and that we thought at the very first time, because, well, if you do some application without thinking about it, then you will be in trouble, I guess, the day you will have to change your events. So you have two ways of doing it. The first one is to say that events are immutables, and the application must be able to read read and handle all messages, new messages, and so on. You must have version of your events and be able to handle them. This one has the great advantage that you don't have, since all the migrations are done in the code, you don't have downtimes when you of your application. The other philosophy is to say, okay, it's really hard to handle everything, and it can lead to some code that is quite hard to maintain. So let's modify the events in the database and only support the latest version of events. So it's more simple for the code, but still it may be also more powerful. I think you can do more with this kind of migration that you can do with the other one. But if you have a lot of events to migrate, then it will give you a greater and greater downtime every time. So, well, I choose to go for the first method, and I'm using a tool that is called Stamina, which is some adapter on akka persistence, which is the event sourcing part of akka, which allows you to migrate your events. So a few drawbacks on that is that all your events must be stored so far in JSON. I hope that at some point I will find some time to work on the Avro support for it. It would be really great. And it uses spread JSON lenses to provide migration. So you can here update your JSON to add some data. The thing you must know for that is that everything must be static. The migrations here must be really fast. And so you cannot just do some database call or whatever, because here this persister here will be called once akka will have retrieved the events from the database and is getting ready to pass them to actor. So it must be really fast and everything must be static. So if you have a date to change, you must give a static date, or you can use a date on your event to just add 5 days or something like that. This is possible. For instance, for us, when we added the country and languages, well, we knew that everything we had in first was in French, so we could add the country France and the language French. It was quite easy for this. Far after 2 years of using it, well, it was quite well. Of course, sometimes it's we would want to do a bit more. For instance, we need to use optional types at some point because we would need them to retrieve data from database, but well, that's something we must be able to handle. Okay, so now with that, we have most of what was interesting in the development side. Let's move on to the upside. So I want to talk on deploying the akka cluster, updating it, well, upscaling, downscaling, and of course failures, which is well, some case that we must be able to handle gracefully. So first, we're using some orchestrator that is called Swarm. So what it does is that you can create services, say, okay, I want to deploy this container, which is some Docker image with some version. You can scale it on your worker nodes. So you can say, I want 3, for example, instances of my application. If one node fails, it will restart it. And it also gives a strong network isolation. So it does well. It does a job, but it doesn't do much more than that. So it's like for the one using Kubernetes, like if you had been coding in Scala for a few years and then at some point go back to some Java project. It does a job, but well, it's like you're quite constrained. But anyway, it's quite simple, and it was quite simple to install and to manage too. So it was good for us to start because, well, when a company starts, they don't have a lot of money, and honestly, using this kind of stuff made our infrastructure way cheaper than using some other services. It allowed us to use bare metal servers and have better performance. So when we wanted to create our cluster, well, Akka provides 2 kinds of roles for that. The first one is the seed nodes, which are just used to create the cluster, to say, okay, I have these nodes, this one is a leader for this one is a leader for that, and so on. So first thing we thought is, okay, we'll deploy some seed cluster and the nodes will connect to it. Great, but we had 2 issues with that. The first one is that the seed were remembering too many containers. And do we really need to remember the containers that were up, well, 6 months ago? No, really. Since we have containers, everything is quite dynamic. So it was not really great. And the other point is, well, that's good, but how do you create the seed cluster? You're back to the first point on how to get your cluster up. So we went to another way of doing things, is that we began using some configuration manager. So we started with Console, where we have all our nodes that were registering in Console. Well, what I did is just once a node starts, it tries to lock some key in Console. If it can, then he uses the seed node and will connect to itself. If he cannot, then he will read the one that is the seed and connect to it. That's great. Why do we need some configuration manager? Well, it's because of the CAP theorem. I don't know how familiar you are with that, but you have 3 points in distributed systems that are available. So it's consistency, availability, and partitioning. The consistency is that at a given point, your data is consistent in all your nodes. Availability is that your service will accept new requests and will answer as fast as possible. And partitioning is that you can have several nodes and that your application can be distributed. So partitioning in a distributing system is one that we always want. which gives only the choice between availability and consistency. Akka is using for its clustering some gossip protocols, which are well, based on availability. And so if we want to have something good, we need some place where consistency is the matter, which is the configuration manager. So the configuration manager will always have the good view of your nodes. And since the nodes then give some heartbeat to the configuration manager, then we will always know which nodes are have heartbeaten and are always alive, and which one will be dead. So to create a cluster, we have a few libraries that we discovered afterwards. The first one was Constructor, which is now deprecated for Akka management, which uses so exactly the same as what I began to do before using it. And you have so consolidated view of your cluster in your database, which is great. And you have then akka management, which is created to create clusters, mostly in cloud environments. So Kubernetes, AWS, GCP, and so on, and using mostly DNS to connect. So it is great for creating the cluster, but you can see that both don't have exactly the same roles and don't do exactly the same. That's why so far I'm still using Constructor. I will explain why later. So next is talking about high availability. So the subjects to cover are upscaling, downscaling, split brain, and node failure. So upscaling, downscaling is quite easy. It's quite magic. So upscaling is just adding a node cluster. So you have a new node. It will know where to connect using the configuration management, and then it will connect, and everything will work really smoothly. Will be migrated to the new node, and so on. It will be available for. It will be responsible for shards, and everything is just magic. Akka for this is really great. Downscaling, well, it's not as magic. It works, but you must make sure that you give to your node enough time to stop gracefully. We had an issue when we started that with Docker Swarm, we didn't define what they call a grace period, meaning that the nodes were killed after some time. And so they were not stopped correctly, and so the state of the cluster was not really coherent after that. But I will talk about that a bit later. One thing that we want to avoid is split brain. What does it mean? For example, just imagine that for some reason the nodes cannot communicate between them. You have node 1 and 2 that can communicate together, node 3 that is alone. And what happened then is every part of the cluster could handle whatever request. It could just start the new nodes, start the new actors, and begin handling every request, which would be really bad, because then you could have 2 writers for a given entity. So what we want when you have a split brain, at least that's what I wanted and what I worked on, is to make sure that one of the part of the cluster just considers itself as being down, being the one that is or that should shut down, and that it would shut down. So to do that, it is the same as what we use later for error detection, is that well, we use constructor and the consolidated view of the cluster for that. So by default, you must know that akka will not downfail nodes, which means that if a node is failed, well, it will still stay here. It will still be responsible for shards, entities, and so on. But since it will be down, well, it won't be able to do anything. So it's that's really the problem that you have to handle with akka. You must make sure that you know how to detect failed nodes and how to remove them automatically. Well, in the akka documentation, they say that when I read it, that you should then connect in GMX to the node to down the failed nodes yourself. Of course, no one would want to do that. I cannot tell my ops, okay, you will wake up at 2 a.m. because some node just failed. Everything must be quite more automatic today with, well, with all these high availability programs. It's quite strange to have to do things manually. So what we do is use constructor, and when some node cannot reach the configuration database for too long, it just will shut down. So the part of the if we have the split brain, the part of the network that will be the good one will be the one that can access the configuration database, even if there's only one node. That's the one will shut down, and once that's shut down, the container manager will restart new nodes and so on, and things should go back to normal. So everything depends on how you configure these heartbeats and after how much time you are considered like as dead. So we have two parameters in constructor that are interesting. One is refresh interval and other one is TTL factor. So one is how often you just do heartbeats, and the other one is how many heartbeats you can miss before being considered as failed. So, well, we have a configuration where after around 30 seconds, a node will be considered as dead, which means that when a node fails, then we think that 30 seconds is something we can afford without losing too many people, let's say, and before the node is killed and another one is started. Next, I want to talk a bit about monitoring, well, which is something, well, we don't talk enough often, and which is really important in production, of course. So we use common Prometheus, which works really great, except that since we are using Docker Swarm and not Kubernetes or whatever else, there is no really tooling for that. So we had to do some tooling to aggregate the metrics of all the nodes so that Prometheus only has one entry point to poll to get all the data. Well, I will be able to show you links and so on that if you ask me later on. So Prometheus, common, excuse me, with akka HTTP provides quite a lot of metrics out of the box. For instance, well, if you configure correctly the operation names in common, you have directly the all the response times and well, the response time in some histogram. So you have the count and the response times, or of any of your operations. You have a lot of more metrics. And what's nice is that it's quite easy to define the well, business metrics, I could say. For example, here we defined a new counter, which is vote trolls, and just have to do the command.counter. It will then either retrieve the counter if it was already created, or create it if it was not. And I just have to call increment, and everything will be fine. It's really great. It's really easy. So just use it if you can. It's really nice. We also use common to know where we came from. That's always a problem when you want to log stuff in asynchronous applications, is that at some point you will be in another thread than the one you started with, and you want to know what operation could this vote, this logging, I mean. So with common, you have some context, and thanks to context, which is propagated between threads, you can know if you work a bit on it, where you came from and have in your logs just, okay, these logs come from a vote operation, from someone registered and so on, which is really great for debugging. So talked about performance, and one of the things we wanted for akka. So we're using Gatling for load testing, and we found out that it's really great. Well, since most of the things are in memory, we have some really good response time, even with quite a good load. And what surprised me most is that akka HTTP, well, since it's using stream, it's very respectful, which means that once the infrastructure is getting slow, then it will stop flooding the infrastructure, and meaning that once the peak is done, is over, then everything recovers gracefully, and once the test is over, you can right away start another one, even if everything was almost dead after the first one. It's really impressive. So I was really glad of akka HTTP for that. So about data and performance, remember that I told you that actors are monothreaded. So at some point, if all the traffic goes on the same entity, well, you will have contention. So the thing to know about that is that the more data you will have, the more hot data you will have, probably the better your performance will be. What the blocking point on that, the contention point, is saving the events once you emit them. Two solutions for that. Some events can be synchronous, let's say. It's blocking, no worries about that. But you will wait for the event to be successfully saved before doing the rest, or you can just set them asynchronously if you need much throughput. So for instance, we have some events like proposing or accepting proposal and so on, which are really which needs to be synchronous, and some other one that we could afford to lose if really the database was down, like voting, which can be asynchronous for better performance. So a few tricky points. So beware of your thread pools. Beware of whatever is blocking, and make sure it executes on another thread pool. So for instance, Kafka consumer just gave us some hard time. Slow network is really your worst friend, since the worst thing in distributing system is some node that works, not works, works, not works, and so on. Serialization is an important point, since every of your message will go to the network. Make sure you think of it correctly. And also, as I said, everything will go to the network. So calling a distant actor is really easy. So know what you're doing, because the system is hiding you quite a few points. So as a conclusion, akka is a really great tool that well, brought to us a lot of value. There is a cost to pay because it's quite hard to understand the actor model and so on. You have a lot of features that, well, you have to work a few things. Maybe using Lagom will just ease a few things because you don't have to know everything. Your akka code will only be used for akka stuff. That's for sure. It's quite unique. That's for sure. And akka will not be a silver bullet. Not everything should be in akka. And well, I hope that Zio and other libraries will just make the pain of the futures out. Well, I guess we'll want to thank you for that. So I guess we're about there on the time. So well, thank you for being there. And our code is open source. So if you want to have a look at it and have a look at what we did to solve this or that problem, you can. It's quite easy. before we start,
Yeah.
I've had a few questions on the chat of
Please start from that. Yeah, it's a good idea.
the Zoom. These were really good questions, so I'd like to start with this. So first one was, how do you handle the NE to unit and type related issues? This is a really good question because, well, I'm using classic actors, and for sure it's not that good if you use it right away. So I will share some my screen if I can find where it is. There it is. So this is some abstraction we've made. Well, we call it our make persistent actor. We'll make it because we are make.org, and that's all. Which is defined so by the state of events, the class of the state, the class of the events, and I also added some auto snapshotting feature, which is now what they're using. They've done some stuff in akka 2.6 for that. So well, we did it quite a long time ago, so we don't have this issue anymore. So which we have now is that we have everything that is more typed, since we have these classes here. So here we say that we need to define some apply event function that goes from the event class to some optional state. No, for the rest, well, we still use the receive command as usual, but well, we have some helpers that we have done to have something more typed. The second question was error handling. So it says that we don't have with akka persistence guarantees for read or writes when we have a lot of data in store. So this is a good question too. First, we have the receive recover method. So which is here, that just says how you can read your data from database. So if reading events fails, then this method will fail too, and the actor will not start. So you do have some guarantees on reading. Well, if it can be failing, but that's all. So this is the first thing. We have an issue where we had a lot of data for some actors, and the actors were taking a lot of time to start. So you need to make sure that you have your snapshots correctly configured. And for the writing, where is it? Here, you have two methods in a few methods in akka to persist events. Sorry, you have the persist method, which will persist your event, and once it's persisted, it will run your code, and no other event will be handled until the persist has completed successfully. If you have some errors, then the actor will crash. You also have the persist async, we just persist asynchronously your events, and you don't know when it will be persisted. And again, if it fails, the actor will crash because you will have some errors of on the persistence side. So this is the guarantees we can have on read and write. So another question was about event migrations, which was why not leave all the events in the code but add new events instead of changes. Eventually they would be eaten by snapshotting. Well, this is another way of doing stuff. It's not bad, but sometimes you only have very minor changes to your events, And I think it's quite a shame to add and add classes every time, because well, all these classes must be handled in the actor, at least for recovery. So that leaves you with a lot of legacy if you don't if you create new classes every time, which will be hard to understand why this event was done at that time, and what's the difference between some event and some other, when was it generated, can it happen again, and so on. It's quite, I think it's quite complicated to just add new stuff every time. Another question was, how do you solve ordering problem while write distributed state to Cassandra? I don't really understand this question, because you have your actor writing writing events. Since actors handle messages one by one, then you cannot have any ordering issue. Also, when your events are persisted in Cassandra, you have some index of your event, so it will know in Cassandra that your event is number 4, then next one is number 5, and so on. So you cannot have ordering issues with that. And last question there was on the chat was, why using a shared state in application over stateless app and even bus? Well, we wanted to keep most of the state in memory to just allow better performance, which is what we have today. I designed this application for performance, though of course it's a bit more complicated, but well, it's so far we haven't had a crash because we had too many people. So I think that's it for the questions on the chat of Zoom. So if you have any questions, please feel free to ask them.
Could you tell me, what do you use as backend for your persistence? For snapshots, you use Cassandra, and for events, you use Kafka.
Cassandra 2.
Ah, Cassandra 2.
Yeah.
How big it is?
Not that much. I cannot say for sure, because well, it's still too big to just list how many events we have. I think we have something like 400 gigs or something like that.
Mm-hmm. Mm-hmm. Thank you.
Which begins to be nice, but it's still small for Cassandra.
Mm-hmm. What is the reason for using persistence? What is the main reason?
Well, in the main reasons, well, first I really like the pattern. It really fits well on well, stuff that moves a lot and so on. And also it's really well fitted for to have applications that are data native, which means that we share, every event is then shared on Kafka, and it's really easier for the data team to then make predictions and so on.
Mm-hmm.
And also, since we have everything in memory, we have performance. That's the main points, I guess.
Do you use Akka cluster, for instance, for horizontal scale?
Yeah. Well, yeah. Since we need we need a cluster sharding, because if you want to do event sourcing correctly, you need to have only one writer for a given entity. So we need cluster sharding to have a guarantee that we only have one actor in the cluster at a given time for a given entity. Which was the main point on well, all the difficulties, or the trouble we had in then managing the cluster and so on. But I think it's really worth the time for that.
One more question. your actors are long climbing. For instance, take an actor, and how deep is its history in the past?
Most actors will have, well, our main actors have some kind of lifetime of 2 months, let's say, because while we're doing some consultations and it usually lasts 2 months. So once it's done, most of these actors just then are not called anymore. We have some other ones which store the user, all the user actions, which are well bigger since they don't have this lifespan, and a few of them just gave us some trouble some time ago. These are the ones that are handling the actions of the batches and so on. Since we have some batches executing every 5 minutes, we had a lot of events just saying that the user connected. But well, since on these actors we don't change the state on every event, well, the batch, it turned out that the batch actors didn't have any state because it was only connecting and doing some stuff that normal users don't do. And so the auto snapshopping we had didn't work because we didn't have any state defined. So we had to trick it a little bit to have a snapshotting working and stopping reading events from the first one.
Thank you.
So far, we don't have issues with reading that could take too long and so on, since we have snapshots on a regular basis.
Mm-hmm. So your application is data intensive, yeah?
Well, it can be, yeah.
Have you tried some streaming processing engines like Flink or Storm for your use cases?
We have some Spark then, but that's all I think we have.
In the previous session, Nathan was asked, Nathan uses mainly Kafka, and he was asked what, if he could do the same with Akka. So I'm going to ask the inverse question. Have you considered using Kafka instead of Akka? And do you think that they in a sense are equivalent because they do their event-based infrastructures? So for example, by replacing each actor by a service and having them to exchange messages through Kafka, do you think you could get the same results as with Akka?
Well, I think both are quite different and have different use cases. We do use Kafka, well, because it's really a great event bus. It's really great, well, for well, all the topics, and the way that we can have different consumers that do different stuff on it. It's really great for that, and we're using it extensively for sure. What we again, what we want is to keep the state in memory and to have some guarantees on who handles what actor will handle which request, which I think Akka is so far the only tool doing it. Well, I think we have some equivalents in the Erlang world and so on, but well, today we're doing some JVM stuff instead. So I'm not sure we could do the equivalent because, well, you have a lot of stuff in Akka, and also, well, Akka HTTP is really great to expose stuff and so on. I think the akka ecosystem is really rich, and I don't see them as concurrent stuff. Just they're just frameworks. They're just tools that can work together.
Okay, thanks.
What are the pain points of using akka persistence? Main pain points, on your opinion, on your experience?
For akka persistence itself, not a lot. You have a few things that are a bit tricky when you learn it, but it's more learning akka, learning to deal with futures and so on when needed to know when you can call the sender method, for instance, when you cannot, and so on. It's more learning akka than learning akka persistent. Persistent itself is, well, quite simple, I think. If you understand, well, if you understand what is event sourcing and so on, we haven't had any really pain point with that.
So it's mature enough and it just works as supposed.
Well, we haven't had any issue with it. I'd be glad to look more on what they have done on the typed actors for persistence, because we're still using classic actors. Well, we have a task to make some pucks on akka type, but well, I'm not sure when we have time for that. Another question I've been asked quite a few times on the Slack was about how if we need that when some event is emitted, we want right away our entity to be directly indexed in Elasticsearch or whatever search engine you use, because we have something quite intensive and we cannot wait for indexation to happen. So, but this is something I've heard quite a few times. It's quite a mess, I think, to do everything on the same transaction and to have the user wait for a response for everything. I understand the use case, but I think it's, well, one of the issues we've had with Elasticsearch and indexing, at first we were doing everything one by one. When an event arrived, we were looking for the new state and persisted it. It turned out when we did our load testing that when doing it, all the processes of the Elasticsearch clusters were about 65% on load during the whole test. Then what we did was bulk indexing of proposals done for us, and just changing that, we went from 65% CPU from almost zero during the test. So it's really important that, I think, if we want to have performance and to keep our infrastructure safe, that we must have them not really coupled and doing one and after another. I think what we should do then, which is quite not easy, but well, which is what we should do, is to have some user experience that is different. For instance, we've had some issues at some time that in our back office we have lists of objects. Then you go on one, you act on it, and it doesn't disappear right away from the list. It happens for our moderation team. So what we did is some special page for moderation, where they just have to click on start moderation. They have a first proposal, they moderate it, then they have a button next one, and so on. And with that we can we can then on the back office side check for every proposal we want to moderate. We can make sure asking the event sourcing part and not only the Elasticsearch part. We can be sure that the proposal we are proposing to moderate can be moderated and so on. So it just changing the user experience can remove all these pain points, but it's not always easy to find how we can change the user experience to make it the same as what we need for asynchronous systems.
What is the most interesting technology around you?
Well, so far I'm not following whatever languages, except maybe Java a little bit, because since we're on the JVM, we must know what is getting on today and when we'll need to migrate to a new version of Java. Well, for instance, we moved very recently to Java 13 because we wanted HTTP2 support, which was on Java 9, I think. Well, we could have used something else to have it, but I didn't want to add a new agent to my JVM and so on. I think it's time for me also to learn at some point a new language. I don't know which one I should do, but I know it's time for me to learn a new one. I've been developing in Scala for 4 or 5 years now, so it's time to, well, to have something to make me think out of the box. Not sure what I will learn later on.
Thank you very much for sharing your experience. It was quite interesting. Thank you.
Thanks.
Have a nice day. Bye.
You too.